In this lesson, we will cover caustics. First, make sure that you have the caustics file opened in Rhino. If you navigate in the scene, you will notice that we have a few objects here. 3 glass vases tinted with different colors that are placed on a rectangular plane and a fill light. Caustics are phenomena that occur when you have a bright light shining at an object, and the object reflects and refracts the light in a manner that splits the light photons up. This results in an uneven or glittering light effect. In this example, we will create a V-ray light to shine at these vases here, and demonstrate how the reflected and refracted light shows the caustics effect. A V-ray spotlight is great for producing caustics, so let's go ahead and select the spotlight tool and navigate in the scene. Let's make sure we have OSNAP enabled and that we have point checked on as well. Also, I have set up ahead of time 2 guiding points, which we can use as a starting reference for placing our light. Now, while holding down Shift on your keyboard, left-click on the guide point located over here next to the vases. The snapping tool should be able to help you position the light with precision here. Now let go of the Shift key, and as you've clicked, drag the mouse towards the second guide point. The cursor will snap to that point. Then, left-click twice on the second guide point, and you have finally set up your spotlight. Next, let's go back to our render camera scene. Open up the V-Ray Asset Editor, and in the Lights tab, you will notice that there is a V-Ray Spot Caustics light, as well as the V-Ray Spotlight we just created. If you're having trouble with your lighting, you can also just enable the V-Ray Spot Caustics that is already there, and disable your own. In this case, I'm going to use the new one that I have just set up. With the one you're using selected, let's go ahead and click on the flyout menu. Now we have a few things we need to do here. First, let's adjust the cone angle and the penumbra angle. For the cone angle, choose something like 35, and for the penumbra angle, let's use 6.3. Next, change the decay to inverse square, and adjust the shadow radius to 3. Additionally, we also need to make sure that the intensity of the light is strong enough so that the caustics will work. Let's increase the intensity all the way to 40,000. Next, down at the bottom of the menu, expand the Options tab, and you'll see the caustic photons below. The slider here controls the number of caustic subdivisions. These ultimately govern how crisp or blurry the effect looks. Keep in mind that the higher the number, the longer it will take to render. On the other hand, setting this value too low can produce noisy results. Let's see what the effect default setting of 1000 here will produce. Okay, now we have a light that is well set up to produce caustics, but we still need to make sure that the material on the vases is also set to produce the caustics. Let's click on the Materials tab, and you will see here that we have a glass material. With the flyout menu open, you will see the V-Ray BRDF material, and underneath that, you can drop down the reflection and refraction settings. Beneath the refraction menu, there is an option for effect shadows. Typically, this option should remain checked, as it's useful for imitating the appearance of caustics in cases where you do not want to actually enable them. However, it is less accurate than calculating the true caustic effect, so we'll uncheck it for this scene. Next, underneath where it says Effect Channels, drop this menu down and let's switch it to All Channels, so that the refraction of the material is distributed in all render elements. Now, let's repeat these steps for the water material as well. Select that material, go to the Refraction tab, and uncheck Effect Shadows. Then, for the Effect Channels, select All Channels. Okay, now we have a light that is going to work for caustics and a material that's set up to produce caustics, but we still need to actually enable caustics. You'll find this option located over in the Settings tab. Here, you will see that in the right flyout menu, we have a Caustics menu drop-down. Open that up and toggle the switch to enable the caustics on. Now, there are a few options below that we will cover in just a moment, but first, let's go ahead and click Render to get a feel for our settings. Okay, let's save this to our render history. Now, if you flip down to the caustics render element, you will see that the caustics here are quite blurry and blotchy. What can we do to sharpen these up? First, let's switch back to the RGB color channel and head back to the Asset Editor. In the Lights tab, let's go to the Spotlight settings. Remember that we did not change the default value for the Caustics subdivisions. Now, let's try increasing it all the way up to 6,000 to see what the effect has on our result. Then let's hit render again. Okay, let's save this render to our history again, and now compare it to our previous render by setting up an A/B comparison. Move the slider to the left and right to get a feel for the difference here, and notice how much smoother and less noisy the latest render looks in comparison. We can also switch to the Caustics render element as well. You can really see here how the higher Caustic subdivisions value significantly improves the look of our image. Now let's go back to the RGB color channel, disable the A/B comparison, and close the History tab. One more thing to note, when using higher Caustic subdivisions, you will notice that your render takes a little longer to get started. This is because it takes longer for the initial photon map to be generated for the Caustics in your scene. However, once the photon map has been calculated, you may find it useful to save that map to your hard drive and reuse it to speed up your renders. Keep in mind though that if you change some parameter of the Caustics, you'll have to recalculate the photon map to update that change. For example, since we have just rendered with 6,000 subdivisions, we can save the photon map so that we can save some time for a higher quality render. To save it, go back to the Asset Editor, and in the Settings tab, you'll see just beneath Caustics that you have a disk caching menu. Click on that, and you'll see that the mode here says New Map, and below that it says Save. Let's click the Save button to save your new Caustics map. Give your file a name, and make sure to store it somewhere that you'll remember. Now, let's say that you want each new render to take advantage of the saved photon map for the Caustics. Click where it says New Map and change the mode to Form File. Then let's select the photon map that we just saved. Finally, let's set up our scene for a high-quality render by switching off the progressive mode so that we have bucket mode enabled. Then, let's slide the quality slider to high and increase the resolution to 1200 by 1200. Now that we are using the saved photon map, our render should be done much faster than without one already preloaded. Okay, you'll notice that as expected, the render started and finished much more quickly this time due to using that saved map, and despite the higher settings. Just keep in mind that if you change anything about the spotlight, using a saved photon map won't work anymore, as it will no longer be accurate. After you've made a change to your light, you'll just need to re-render your scene and save a new photon map.